Alright, so time for whitewater. So turn off, well, pretty much turn off anything that's on. And we'll banish this rest demo thing to the land of wind and ghosts, and then we'll make a geometry node here to be our new whitewater source, rather. So whitewater source. The whitewater source is going to be based off of the cache of our liquid sim. So over here, we want to object merge in the liquid sim. Oop. There we go. You know, it has that crunchy looking compression thing, but that's fine. Drop down a whitewater source node, connect it like so. So it thinks about that for a second. Now we don't really see anything. There's two things we need to do. One is on the volumes tab, which is actually kind of the main tab all the way over here on the right. The voxel size should be hooked up here, like so. Output volumes we actually don't need to turn on. It is already outputting a volume called emit. This is the one that the solver wants. Now we still don't see it. It is there, it's just very, very dim. If you make a volume visualization node and you set it to emit, which is what it's called, and you scale it up. Oh, there it is. So it's there. It's just very faint. Even bigger. Now this isn't actually changing the volume, it's just changing the way it's being displayed. So don't worry about that either way. And at any rate, we'll just say that this is going to be the source here. So anyway, coming back to this, output volumes means that you should also output this surface and vel thing. We don't need to do that. We only need the emit here. So that's fine for now. The way this works is that this is going to generate areas on here via this volume that denote where whitewater should be sourced. So this will go into the whitewater sim. The whitewater sim will spawn particles in that volume. The particles are what is actually simulated based on the velocity fields of the initial liquid simulation. The particles are what it comes out of the sim, and then you convert that into volumes. Now, a nice convenient thing that they have here is under visualization, you can say source particles now. These do not go into the sim, but they will approximate what the sim will be doing. Now I don't see anything right now because this number is too big. If I were to make this much smaller, like here, now we have something. This is how we will visualize what this is even doing. So looking at, for example, acceleration, vorticity, curvature, these all contribute, and as you can see they have different colors to denote their contribution. It all gets wrapped up into one emission volume though. So that's why we really always want to see this source particles business here. So ground rules are that by default, the speed, none of this will even matter. The curvature, the acceleration, the vorticity, none of that matters if it doesn't at least meet this minimum speed. So 2 means 2 meters per second. How do we know how fast this is even moving? Well, once again, we can come back to liquid cache. Thought we still had an unpack. I guess not. Looking at this, we have, we used this earlier to look at things like, oh, what does the vorticity look like? Oh yeah, my Houdini crashed before, so I lost that. When we were looking at this, we had set this to like 20 and 40, and that's what our vorticity was. We can look at other things instead. We can look at the velocity, which is a bunch of velocity vectors, kind of hard to say. Let's actually look at the speed. Well, the speed doesn't exist as an attribute. The speed is inherent to the velocity. So let's just make a speed attribute. And what I mean by inherent to it is how long is that velocity vector. The velocity vector is both the direction and the speed. The direction is, the way it's facing. The speed is how long it is. So now looking at this, we can look at speed and see, well, the fastest stuff in my sim is moving upwards of 8. And much of it, let's say right around here in the middle, it's going about 1. So there you go. So I have some stuff that's moving quite fast up here, but much of it's not. And that's fine. I don't want whitewater to be spawned everywhere. I just want it to be in these areas of interest. But all of this is to say, if you were to make this lower, you're going to get a lot more all of a sudden, because much of our sim was at least 1. And now it's doing so many, it looks like that it's really thinking about this. We're probably making too many points here. I'm going to go to somewhere around here. In any case, this is too much. So go back to the default. If you don't have as much speed as my sim does, you might need to bring this down somewhat. But I made sure that I knew this rock would cause some high speeds. As it whips around the side here is when it's going quickly. So and that's what we can basically see happening. So let's go through this. We have curvature. Curvature is mostly for oceans or breaching effects that causes waves, like waves that have sharp edges and things. That's what this curvature is looking at. It's looking at the volume, the surface here, and saying, where is it so sharp that this would cause foam to occur? That's where you see on the beach when a breaking wave creates foam. So that's a fairly common and important thing there. I'm going to say we probably don't even want it at all. We're going to lose some whitewater, but I don't know that I really even want whitewater from waves here. I mean, these waves, I want whitewater here because of the speed and vorticity, but I don't think any of these waves are worthy of making actual foam. So I'm actually going to turn off emit from curvature, straight up. Acceleration. Acceleration means change in velocity. When does the velocity change? Well, usually collisions. So when things collide suddenly. Now a lot of these collisions are smoothed out because it's liquid, but nonetheless, you can see there is some. These green dots here are some. Like anything, the lower we make this, the more we'll see. So it's funny, even at 0, it's not covered in acceleration because, again, it's being limited by the speed range here. So we can always force more particles on, but the point isn't to force them on. The point is to have them only in areas that are interesting to us. Maybe I want to bring this down a little bit, something like that. And maybe something like that. There's no, this is all tweaking. This is going to be a lot of your job when dealing with water simulations, is tweaking these kinds of parameters. I'm going to try to get something as good as we can as quickly as possible. Vorticity is the main one, though, because of this kind of sim. This is what we're seeing. I can close this. Again, vorticity here. We already know there's a lot of vorticity here because we're shading based on that. And so it's no surprise that it's showing up in the same area. As for what that should look like, I would say this is already pretty good. This would be at least pretty good for a first pass. We can see how that plays out. So I'm going to say this is good for now. We can also always increase the density of the result of the sim and things later on. So this is a good first pass.